This is video number 12 of a series on foundations of arithmetic, algebra, and graphing with a focus on real-life interpretation and application. I'm Bill Kinney. As I said, this is video number 12. It's a second block of videos. The first block going through video number 11 focused on the integers. Starting with video number 12 here, we're getting into something called the rational numbers, also known as fractions. So this is part one of that sub-series. And so we want to get into how to add, subtract, multiply, and divide rational numbers, and also focus on the real-life interpretations of those. And in this video, we're going to focus on one example. One of my favorite topics, pies. My mom made 2 apple pies of the same size. She cut the first one into 3 equal slices and the second one into 4 equal slices. Kind of big slices there, but bear with me here. Since they're so big, we're not going to have a person eat them. It's going to be my dog. My dog came along and ate 1 slice from each. Maybe they were already cut out on plates or something, or he was very good about just picking out 1 slice from each. 2 questions. How much pie did my dog eat overall? How much in both? And how much pie was left? Alright, so let's think about this by visualization. I like visualizing things as much as possible. I can't draw perfect circles, but I'll do my best. Let's pretend this is the first pie, and this is the second pie. They're supposed to be the same size, and they are both apple pie, let's say. This one's supposed to be cut into 3 equal pieces, so that would make the pieces, if this is the center of the circle right about there, about like this. This is definitely not a perfect drawing. Just pretend that these pieces are all exactly the same size. It's a little easier to draw in the second pie 4 equal pieces. Just make a plus through the middle here. So the pies overall have the same size, but you can see because you're slicing them into different numbers of pieces that these pieces are different sizes. These pieces over here are bigger than the pieces that are over there. So the dog ate, let's say, this piece there and this piece there. How much pie did the dog eat overall? Well, the key thing to thinking about this is realizing that 3 and 4, 3 pieces and 4 pieces, 3 and 4, the numbers 3 and 4, those integers divide evenly into their product. In this case, 3 times 4, which is 12. 12 is also sometimes called the least common multiple of 3 and 4. And because of that, because 3 and 4 both divide evenly into 12, and you can break up these pies into 12 pieces each in such a way that for each of the 3 slices over here, you've got 4 sub-slices, so to speak. These are all supposed to be the same size. See that? For each of those 3 slices separated by the red lines, you've got 4, 1, 2, 3, 4 sub-slices, giving you 12 equal slices overall if you split it up like that. And over here, you've got the 4 equal pieces. They can each be split up into 3 sub-pieces, giving you 12 pieces overall that are the exact same size as the 12 pieces over here. Got to be a little more careful here. These are 3 sub-pieces of the same size in each of the sections. A little harder to draw, and I'm not doing a perfect job. Yeah, that one's bad. Like that. Something about like that, definitely not perfect. But again, for each of the 4 big pieces, there are 3 sub-slices. And now once I've done that, each pie is into 12 pieces, equal in size, and equal in size compared to each other as well. because the pies overall are the same size. So again, remember where the dog ate. The dog ate in here and here. And because I've now broke each pie into the same number of sub-pieces, so to speak, it should make sense that if you think of those in terms of those sub-pieces, we can just add them up to figure out how much pie the dog ate overall. 1, 2, 3, 4 sub-pieces over there, and 1, 2, 3 sub-pieces over there, giving you 7 pieces overall. So effectively, it was as if out of 12 equal pieces from one of the pies, the dog ate 7 of them. In fraction notation, which hopefully you remember, we can represent this as saying from this pie the dog ate 4 out of the 12 pieces, or 4/12 of the pie, and from this pie the dog ate 3 out of the 12 pieces, or 3/12 of the pie. Altogether, the dog ate 7/12 of the pie. When you got fractions represented this way, where both of these numbers on the bottom, the 12s, are the same, these numbers on the bottom of the fractions are called denominators, then you can add the fractions by keeping the denominator the same, 12 over here, and just adding the numbers on top. The numbers on top are called numerators. So 4 plus 3 is 7, that's where the 7 comes from, and the 12 stays the same. And the reason why this makes sense is because of this kind of picture. At least in this kind of example, that's why this kind of thing makes sense. 4 out of the 12 pieces from that pie, 3 out of the 12 pieces from that pie, 4/12 plus 3/12. Overall, the dog ate 7 equal pieces out of, as if he had eaten out of one pie. He ate 7/12 of a pie. In terms of the initial fractions, the initial cutting, over here the dog initially ate 1 out of the 3 pieces. Over here the dog initially ate 1 out of the 4 pieces. It's the same amount of pie. 1/3 is equivalent to 4/12. These fractions represent the same amount of pie. 1/4 is equivalent to 3/12. So because of that, 1/3 plus 1/4 is also 7/12. And how you go about calculating this initially is you convert these fractions to equivalent forms involving a common denominator. The 12s there are the same. Initially, the fractions don't have a common denominator. You must convert them to equivalent forms that do have a common denominator, and then you can add them in this way by adding the numerators. 4 plus 3 is 7, and keeping the denominator the same. As far as how much pie was left, well, and both pies overall there were 2 pies. The dog ate 7/12 of a pie. I need to do that subtraction. That should make intuitive sense. In order to do that, I need to write 2 as a fraction. I wrote it here as 2 over 1. I didn't have to do that initially, but just to emphasize that I can think of it as a fraction and write it in an equivalent form involving a denominator of 12. When you split the pies up into 12 pieces each, you had 24 pieces total. 2 is the same as 24 over 12. When you subtract fractions with a common denominator like this, just like with the addition, you subtract the numerators. 12 minus 7 is 17, and keep the denominator the same. This kind of thing is sometimes called an improper fraction. You can split it up into 12 over 12 plus 5 over 12. In effect, you can think of it as 1 plus 5/12, or sometimes written as 1 and 5/12. When you write it like that, you call it a mixed fraction. And what that means is, how much pie is left? Well, 1 whole pie plus 5/12 of a pie, 17 pieces total out of the 24 smaller pieces. That's how much is left. So we'll do more examples in coming videos, but that's the end of this one.